Hello 108 students, Mr. McCue again, back with you here on section 10.1 like we've been working on, one-to-one functions, and we are going to work on our page 5 of our class notes here. Okay, as we continue on here, we have example 3C that is going to challenge us just a little bit, because when you look at it, it says f of x equals the quantity x minus 2 raised to the third power. Okay, now I kind of gave you a heads up on the last page, page 4, when you're raised to the third power, you're talking about a cubic function. And I kind of cheated and told you it was going to be a one-to-one function. But let's just do a flashback, and let's go back to section 5.3, and let's graph the parent cubic function of y equals x to the third. And let's see if we can use our vertical and horizontal line test to determine that it's a one-to-one function. Okay, so if you are a tad rusty with cubic functions, go back to page 5.3, objective 5, and I quickly graphed it. You could do the XY expanded table like we've done before, pick values for x, find the output values of y, and match the ordered pairs. What you get here is a graph that looks like, I call it a propeller shape, kind of interesting, that cubic function. And now we're going to ask ourselves the question, is y equals x to the third a function? So we're going to go ahead and begin and draw ourselves a couple vertical line tests. And as I draw them, I'm crossing the the cubic function of the graph one time, and it looks like we do pass the vertical line test, so we can safely say y equals x cubed is a function. Now our challenge is this a one-to-one function? I turn around, I start drawing some horizontal lines. Oops, try to draw them horizontal, excuse me. And it crosses the propeller only one time when I do it. Okay, so we've just proven there real quick visually that a cubic function, all cubic functions are one-to-one. And so that takes us back to the original problem of y equals quantity x minus 2 raised to the third power, and let's go through our steps. First step here is, once we write the original equation, is to interchange the y and the x variables. You simply swap x for y and y for x. And once you've done that, you now ask yourself, how can I isolate that y variable? Okay, now we're on a little bit challenged because we've got parentheses cubed, and I'm trying to go through my brain and remember, how can I undo cubing? And then I remember, just like squaring, you undo it with a square root. We are going to take the cube root on both sides of the equation. Okay, that's our ticket here to isolating the y variable. When I take the cube root on both sides, don't forget cubing. Cube root undoes cubing. These all go away. Oops, excuse me. Sorry, I want to take that back. I apologize. I want to keep that here. We need to keep it here. I'm on the wrong side. Cubing and the cube root of it undo each other. I apologize for that. Dropping you down the radicand, and you've got y minus 2 equals, on the left hand side, the cube root of x. Now, I made that mistake over there. There's nothing inside this radicand that's got a cube to it, so therefore you have to keep the cube root in the cube there. Okay, now that we've got that, the parentheses you're looking at here don't do anything. You could pop up a 1 and do the distributive property if you needed to, but basically you're only left with one last step of how can you isolate the y variable. Add 2 to both sides of it, and that's going to give you the result, the cube root of 3 plus 2, and that's, remember, that's outside the radical sign right here, equals y. Your last step is to replace y with our notation of f inverse of x, and again that's f raised to the negative 1. Okay, and that's all you have to do for that problem. So we're pretty straightforward with the three steps we just talked about. And now, objective number 4, we're going to get into graphing, and we are going to work with linear equations here. Challenge is to graph the f raised to the negative 1 or f inverse function from f, which is a linear equation. Okay, so our first step here is to say the function f must be a linear for these steps to work. Number 1, graph the linear equation of the function. Don't forget y equals mx plus b. This is from chapter 3 for reference. The coefficient in front of the x is the variable, is the coefficient m is the slope. Remember, that's rise over run. B is your y-intercept. And we turn around and graph that real quick. I'm going to find the y-intercept and calculate the slope once. Once you've got the line graphed, you got two ordered pairs. We're going to list them, and then we're going to interchange the x and the y's to give us the one-to-one inverse function. Plot those new ordered pair points as part of the inverse function and draw your second line. Okay, now here's the example we got going here. F of x equals 2x plus 1. Okay, way back from chapter 3, identify the slope, m as 2 over 1. I got that from the coefficient in front of the x. Remember, rise over run, so I divided by 1. The y-intercept is plus 1, and that means the ordered pair is going to be 0, 1. So I'm going to come up to 0, 1 and put my first dot. And then I'm going to go ahead and execute the slope, which is up 2. Slope is rise over run, so I'm going to go up 2 units over 1 unit, and I've got my second red point. And now I'm going to draw that line and go through it. Now I'm just going to kind of give it a couple dashes here so you can kind of see the line here. Okay. Now, done that before. That's just a quick review. The fastest way to do these is to now realize you list the two ordered pairs from the function 0, 1, 1, 3, and then you're going to swap the x and a y, so 0, 1 becomes a 1, 0. Swap the x and y coordinates, and when you swap them, you still, in graphing, this is the new x, y. Same thing with the second ordered pair we found, 1, 3 becomes 3, 1 for the inverse function up here. Okay, and now my graph, I apologize, I made a mistake on this, so what you want to do is find 1, 0, well this is accurate right here, and then 3, 1, I went down instead of up. I don't know why I did that, so you got to be careful. 3, 1 would be right here. And next you're going to go ahead and draw the line between the dots. I'm going to sketch this in here as best I can. Okay, now I'd suggest you kind of do this on your own paper here. I'm struggling a little bit with the graphing of it. Now this line I did right here is wrong, so try to clean that up a little bit. Notice here that you're done with as far as the problem goes. What we have right here is y equals x. The book wants you to realize that's called the axis of symmetry. Both of these, the function and the inverse function, rotate or symmetrical to that y equals x. Okay, so they're just kind of introducing that concept to help you in 143. Okay, so hey, we've done page 5. We got one more page to go. So I'm going to say goodbye for now, but I will see you on page 6 to finish up the last section.